Assalamualaikum and hi, my name is Mohammad Iqbal Afiq bin Mohammad. My university is Universiti Tun Hussein on Malaysia, UTHM. My supervisor name is Dr. Khairul Anuar bin Mohammad. My reference number is 153 and my title is Development of Solar Powered Remote Fluid Level Monitoring System. So for the first, we go through the introduction. The Malaysian economy ranks 35th globally and it is the third largest in Southeast Asia after Thailand and Indonesia. Petrochemicals and oleochemicals are the main product of this sector, which plays a significant role in the Malaysian economy. The level measurement technique is essential in many industrial activity, especially petrochemical and oleochemical. This can be straightforward or difficult process depending on the type of material being measured. Some of the material are chemical and petrol, like diesel and petrol. Process engineers are looking for more accurate and dependable level measurement system. Solar energy can be used in all areas of Malaysia and it is accessible every day. The best thing about solar power is it will renewable, infinite, and unlike some of the other source of energy, solar power will be always reliable and cheap. We continue to the problem statement. In the problem statement, we state the problem that we want to solve by making this project. So for the first, for the right now, we could require a lot of workforce to make the manual inspection of each tank, which could increase the process time. Second, higher cost of electricity, which increasing the plant operation cost and sometimes power outage also happening in the plant. And for the third, obstruction of the fluid sensor could make the inaccuracies and inconsistent of the data. And for the last is fluid sensor are unreliable and easily broken if not being maintained on regular basis. For additional, fluid sensor also sometimes happening on sticky sensor that most of the industry face this. We continue to the project objective. For project objective, we have three objectives, which is for the first is to design a solar power level monitoring system using ultrasonic sensor for remote monitoring system. Second is to develop the prototype model for remote monitoring the fluid level monitoring system and solar panel to power up the system. And for the last is to integrate the remote monitoring the fluid level monitoring system and controlling the fluid level between each tank by using Internet of Things IoT by using an application. So for the application, we have application and software browser to control and monitoring the fluid level tank monitoring system. So next we will be continue to the project scope. For project scope, we have the to create a device that can give a real-time data of important parameters such as fluid level and flow rate, then controlling the fluid level between each tank by using remote operation. The second is the hardware module that will be used in this project is Arduino i3 microcontroller, flow rate sensor, waterproof ultrasonic sensor, Wi-Fi module, solar panel, solar PWM controller, voltage measurement sensor, and rechargeable battery like lead acid battery. And for the last is the real-time data should be seen and can be controlled by using Bilink application dashboard. So that's all for the project scope. Continue to the novelty of the product. So for the first is the implementation of Internet of Things that following Industry 4.0 standards. The next is solar power provide reliable and sustainable energy for fluid level remote monitoring system. For the third is we can remotely monitor and track tank level in real time without need of manual inspection. And for the last is operator can monitor and control the tank level from the long range just by using application or smartphone application like Bilink. So next we will be continue to benefits to intended user. For the first is safety. We could reduce the risk of the accidents and injuries by allowing technician to remotely control and monitor equipment and system. Next is efficiency. Remote monitoring provide real-time performance feedback and quick and precise troubleshooting. And for the operation cost, we could reduce the need for on-site visit, reducing the cost and minimizing the time caused by equipment failure and power outage. And for the last is predictive maintenance. By provide early warning of potential equipment failure, allowing for proactive maintenance and reducing downtime. We go through the commercial potential. So for the first, this project could be used in various of applications like agriculture and industrial tank and home use. It also can monitor various sets of data like flow rate and temperature. Second is the needs for increased safety and efficiency in industrial operation demand remote monitoring solution. And for the third is industrial needs on a standalone system that need to be accessed remotely and allowing for monitoring and manage anywhere. And for the last, increasing demand for automation and data-driven increase the market of this project. So that's all from me. Thank you and Assalamualaikum.